Hello and welcome to my new video series, the Computer Number System. Alright, this is the first video in this series, and in this video we're going to explore the decimal number system. Now, computers don't use the decimal number system, but humans do. So I'm going to approach this video from information that you might already know, but how do you know it? And then the videos after this video are going to deal with the binary and hexadecimal number systems and how to convert between these three number systems. This is really a kind of a fascinating topic. When you really learn this, you will learn how computers operate, and it's just great. You'll see a whole new dimension to your computer use. Alright, so let's get started, shall we? Alright, humans use the decimal number system. The decimal number system is a base 10 number system. It uses the digits 0 through 9. So if I take a decimal number like 126, we know this is 126, but how does it add up? And, somebody might say, well, you take 100, you add 20 to it, and you add 6 to it, because 100 is in the hundreds place, 20 is in the tens place, 6 is in the ones place, so you add it up and you get 126. While this answer is correct, we're going to look at a more scientific way of coming up with this answer, besides just a simple math answer such as this. Before we look at this method, though, I do want to review some information on exponents. If you didn't get exposed to exponents in your mathematics classes, or maybe you did but you don't remember it, things like that, let's do a brief review. Exponents are numbers in superscript. So in this example here, the 3 is the superscript and the 2 is the base. So I would say this as 2 to the third power, or anything to the third power can be said as base cubed. So this could be said as 2 cubed. Alright? And this exponent tells us how many times to multiply a number by itself. So 2 cubed, or 2 to the third power, would be equal to 2 times 2 times 2, or equal to 8. Alright, well, this is neat information, but how is this useful to us? Well, let's look at some exponent facts. There's really only two of them that we have to remember, and that is a number to the first power is equal to that number itself. So 2 to the first power is equal to 2. Very simple, right? Okay. A number equal to the 0 power is equal to 1. So 2 to the 0 power is equal to 1. Even 0 to the 0 power is equal to 1. Right? That's kind of a little neat factoid for you there. But now that we know this information, how is it useful to us with number systems? Right? Well, if we go back to our original problem, and that is, we know this is 126, but how does it add up? I made a table here of information. I've taken the leftmost digit, I've put it in the first row, I've taken the other digits and I put it in the subsequent rows. Okay? Now, over here, on the last number, I have 10 to the 0, and then I work my way up, increasing the exponent by 1 with every row I go up. So I have 10 to the 0 power, 10 to the first power, 10 to the second power, or 10 squared. Alright? And then once I do all the math, break it all apart, I have I have 1 times 10 times 10, which is 100. I have 2 times 10, which is 200. And I have 6 times 1, which is 6. Because 10 to the 0 power is 1, adds up to 6. So if I take these numbers, I add them up, I get 126. This is a more scientific way of doing it. This information may seem a little verbose right now, but when we do get into our discussion of binary numbers, you will see why this method works better than just the 100 plus 20 plus 6 is 126. Alright? So, I want you to try this yourself. Alright, using the following exponent method, using the exponent method, break the following decimal number down. And the decimal number you're going to be breaking down is 2,368. Alright, so pause the video, use the method that we just used to break this number down. Make the table and everything else like that. Make the table, it will help you out. Make the table, make the table, make the table. Pause the video. When you're ready to see the solution to this problem, click play. Alright, welcome back. This is the solution to the problem on the previous slide. And what I've done is I've just taken the leftmost number, I've put it in the first row, and I've put in the subsequent numbers below it. Then, on the last number, I move over to the next cell, 10 to the 0 power, and then I go, every row I go up, I increase the exponent by 1. Okay, so I wind up with 10 cubed, or 10 to the 3rd power. Now, once we do all the math here, it's 2 times 10 times 10 times 10, which is equal to 2,000. 3 times 10 times 10, which is equal to 300. 6 times 10, which is equal to 60. And 8 times 1, which is equal to 8. So I wind up with the answer 2,368. Alright, so if you didn't get this solution or this table or this data in this table here, look at your answer, compare it to the solution on the screen, see where you kind of went wrong, maybe you miscalculated somewhere or something like that, and learn from that experience. Alright, the math behind this is really surprising because we take numbers for granted sometimes, I think. So we see a number, we know it's that number, but how do we know it's that number? Alright, and the next video, we're going to look at the binary number system, and we're going to see how the binary number system is similar to the decimal system. It's this variation on a theme. Okay, so I look forward to seeing you in the next video. Thanks for watching this video.